Okay. So I'm pretty sure that the last thing I did with you was talking about this thing on this table. This is part of work 1. This was where we stopped in the corrections while you were in school, well, a few days ago. So this was about fractional distillation because we are trying to separate out the many fractions. So it's not a simple distillation. Simple distillation is when you only have 2 components in a mixture, like water and salt. Water and salt from seawater, you do simple distillation. Ethanol and water, you do simple distillation. Crude oil, you will learn eventually in year 11 organic chemistry. There are many fractions, some of which have very low boiling point, some of which have very high boiling point, and therefore you will be collecting them many fractions. That's why it's called fractional distillation. In terms of the boiling point, these are given. Room temperature and pressure, some people didn't quite understand, that was 25 degrees Celsius. So this is way below 25 degrees Celsius. You already boil. Minus 42 is way below 0 degrees Celsius. You already boil. Before you reach there, it's a gas. This is above 25 degrees Celsius. You have a boil. You use ethanol in your hand sanitizer. Hand sanitizer contains some components of ethanol. Therefore, it's definitely a liquid. Now, this was the calculations that many of you couldn't quite get. In fact, I think like a quarter of the class left it blank, left it empty. It's pretty sad that you give away the 3 marks, and it's even sadder and a disappointment that you chose to give up the 3 marks even in exercises and homework. Homework, do at home. Exercises, do at home. Therefore, it's your job to actually try and not to give up like that. Unless you already give up, then there's nothing I can do. This is 1 kilogram of propane. They give you this much energy. There is no need to convert this to mole. There is no need to find the mole of propane because this information is given. They want you for ethanol. When you are doing questions, you are not a very good reader, and therefore you need to circle and underline information. They want ethanol, and this is per kilogram of ethanol. The information given is per mole. Therefore, you have to find in 1 mole what is the mass of the ethanol. But we want per kilogram compared to propane. So we want 1 kilogram of propane, 1 kilogram of ethanol. Converted to gram is 1 kilogram is 1,000 gram. Because mass over MR, the mass has to be in gram, divided by the correct MR of ethanol, which of course we show our working one by one. This is kilojoule per mole. This is enthalpy. Enthalpy is not energy. Energy is joule or kilojoule. Enthalpy is to do with stoichiometric amount. Stoichiometry was that year 9 topic called mole concept. So per mole of ethanol, you give out minus 1367. You release this much energy. So you release that much energy for 1 mole. So when you have 1,000 gram divided by 46, this is how much mole of ethanol. Multiplied by that, as you know, mole multiplied by kilojoule per mole. That is the meaning. Per mole multiplied by mole. The mole will cancel, and you will get your final answer in kilojoule, which is energy. That's why your answer there is energy released by 1,000 gram, which is 1 kilogram of ethanol. This energy is much lesser than 5,540 kilojoule. I made a bit of mistakes in marking your work previously. So some of you talk about it release lesser carbon dioxide. So that is actually correct. It does release lesser carbon dioxide. But some of you said that it's a clean fuel. It is not a clean fuel because it does produce carbon dioxide. If you think about combustion, this word called combustion. Combustion means burn in oxygen. Burn in oxygen. When you burn something in oxygen, you will always release energy. It's always exothermic. And then you will get 2 products from complete combustion. The first one is called carbon dioxide, and this is water. Okay, the carbon dioxide that has to be balanced because even year 9 student knows whatever equation you write has to be balanced. So 2 CO2 because of 2 carbon. 5 plus 1 is 6 hydrogen. So I need 3 H2O there. So that altogether is balanced now. Now I have 3 oxygen and 4 oxygen. I have 7 oxygen. Don't forget you have 1 oxygen there. Again, number 1 favorite among examiners, among exam questions. Students forget that there is 1 oxygen there. 7 oxygen atom minus 1. You need 6 oxygen atom. Cannot change the identity of oxygen molecule. So I get 3 times 2, which is 6 oxygen atoms there. Okay. So people who say that it doesn't release greenhouse gas is definitely wrong, because this is CO2. It's the same thing you get when you burn petroleum. In terms of diagram like this, energy profile diagram, typically I will write chemical formula, but here the question specifically say, show the names, plural. It's called reading plural and plural. If you write one product, you don't write the other one, you don't get the full mark. Label activation energy. Activation energy from the start to the top of the peak. Do not draw a half-hearted arrow like this. You know, like you don't show from the start, you show like halfway there. That is actually wrong. It has to be from the start to the top of the peak. Label it capital E and then subscript A, activation energy. They don't ask for the enthalpy change. I've just labeled it for fun here. I don't get any additional mark. From the start to the end. From the start to the end. There is enthalpy change. It's going downwards. Therefore, it's exothermic. Combustion is exothermic. Today, you might have had breakfast. When you had breakfast, you are eating at home, you are burning food in your body. Your body is warm. If you are dead, a dead person, the body is cold. Your body is warm, around 37 degrees, around that temperature, is good because your body is burning the food inside your body and releasing energy. That's why you eat food, so you have energy and you are breathing out carbon dioxide and water. The food that you are burning is glucose or carbohydrate plus oxygen. And then when you burn, you get CO2 and H2O. This is what you call respiration in biology. Respiration is the opposite of photosynthesis, because photosynthesis is carbon dioxide and water producing your oxygen and food, carbohydrate. Not necessarily glucose, but also sugar. Essentially, it's carbohydrates plus oxygen burns to give you carbon dioxide, water. Your body feels warm because burning carbohydrates is going to be combustion of carbohydrate. It's going to be exothermic reaction. This is an example of endothermic reaction, activation energy from the start to the top of the peak, enthalpy change from the start to the end of the reaction there. I did talk about oxidation number in my tutorial video. Not too sure if we've gone through those, but oxidation number, nitrogen 2 oxide there, that is actually nitrogen monoxide. The molecule has a 0 oxidation number because the molecule, just like a compound, has no charge. The nitrogen there is what you want to find. Oxygen in a compound has a -2 oxidation number. The nitrogen is +2 there. Therefore, it's nitrogen 2 oxide, oxidation number of nitrogen there. Typically, you will see that we write chemical symbol unless specified by the question. Going upward from the start to the end, endothermic. From the start to the top of the peak, activation energy. Now, this question is asking you exo, endo. You focus on the energy of the reactants. Some people write down the full essay on bond breaking is endo, bond forming is exo, blah, blah, blah. But when you look at the marks, 1 mark for labeling, 1 mark for these, they give you the graph. Why do they give you energy profile diagram? Hazika couldn't get the x-axis last time because she was just copying everything. So that means she didn't even know what is energy profile diagram. Energy profile, it tells you how the reaction progresses in terms of the energy of reactants and energy of products. The reactant, which is the system, must have absorbed the energy from the surrounding. That's why the products have higher energy than the reactant. And because you absorb energy from the surrounding would lose energy and your surrounding will get cooler. Energy profile diagram is for the system. Last but not least, these are the kind of essay question. This was part of a 10-mark section B question. Section B question tends to be a bit longer, but this can also be a section A questions. People couldn't quite do the essay in the work, but I hope the last lesson kind of show you that it's actually pretty easy. So state that bond breaking is endo, bond forming is exo. Of course, this could be the other way around, doesn't matter, as long as you state both of them. And then we know enthalpy change is the sum of energy to break. You break everything for the reactant side, so bond breaking there, minus the sum of energy that you release when forming bond. So bond breaking minus bond forming, you break everything in the reactants. You have 2 of that. So, you know, you actually have 1, 2, but you have 4 OH because you have 2 of this molecule, and you have 1 OO single bond, but actually you have 2 of that because you have 2 molecules of these. You are forming 1 mole of this oxygen-oxygen double bond. and you're forming 4 of these OH because in one molecule you have 1 and 2, in 2 molecules you have 4 altogether. But they don't ask you on the calculation here, they do in the work 2, that was part of the multiple choice questions. Draw the energy profile diagram for 3 marks, label activation energy and enthalpy change. Typically, I don't want to write the names unless the question is specified, and therefore what I do is I write the formula. As you know, this is one of the way I can produce oxygen gas in the lab. This was in the presence of something like a catalyst, okay? So this is without catalyst. If I use a catalyst, it's going to be faster. If I use MnO2, this was the black color solid. I show you during the gas collection when you were in year 9. This one was produced as a lot more bubbles because the reaction is faster. So catalyst will speed up the reaction, speeds up the reaction. It makes the reaction go faster. In terms of this diagram, this is an activation energy for the uncatalyzed reaction. So let's say that is uncatalyzed reaction. I'm going to draw in something else, which is for the catalyzed reaction. So now this red color one, you see, it's easier to overcome these mountains. It's easier to overcome this much activation energy because I use a catalyst. So this is activation energy, catalyzed. Catalyzed means I use a catalyst, whereas the green one there is not catalyzed. This is not the answer for this question. I am just adding. What if you use a catalyst? Okay. So your answer just need to have one activation energy and the reactant, the product, and the enthalpy change and activation energy. I am just adding, okay? I just want to highlight, I am just adding in this thing which are catalyzed, lower activation energy, easier to overcome the mountains, easier to overcome the activation energy, therefore faster rate of reaction. So when is the reaction faster? When the activation energy is lower. When activation energy is higher, it takes you some time to go over to the other side because you need to overcome activation energy. Doesn't matter if you are exo or endo reaction, you must overcome activation energy before you can react. Okay, just so you know. This is not the answer required in this question. Sometimes they will ask you, draw another reaction profile diagram, energy profile diagram, or reaction profile diagram to show the activation energy for the catalyzed reaction. As you could see in the catalyzed reaction does not change the enthalpy change. The enthalpy change is still exactly the same. Only the activation energy is lower, but the enthalpy change is still the same when you use catalyst. Okay. Anyway, let's go through work 2. I don't want to have to go through every single questions, but why don't people just shout out what question they want me to go through? Okay, just unmute yourself and shout out what question you want me to go through. The faster you shout out, the faster.
Question 18.
Sorry?
Question 18.
Question 18.
Yes.
So answer is answer, yeah? I mean, like people treat MCQ as if they are very easy, but they are not, okay? Now, this question is all about reading. We know hydrogen is used as a fuel. That was your last topic called fuel cell. In the fuel cell, in electrolysis, hydrogen is not the product. Hydrogen is the reactant. Oxygen is the reactant. And you produce liquid water. And of course, you must balance the equation, 2 and 2 there. So gas and gas goes in there. It produces energy. That's why you can use it as a fuel cell. This is exothermic. That was why we did this in the last topic. And now you're relating the last topic. Fuel cell because it generates energy. You think about going backwards. Now I am going to split water. I need electricity. I need to electrolysis. I need electricity. So that thing is endo. But this thing is exo because we are talking about two sides of the reaction profile diagram. If one way is negative, you're going the other way. The opposite way is endothermic. Okay. This one release energy. That's why that energy could be used as a fuel cell to do some other function because it releases energy. Used as a fuel, yes. When you burn in air to form water, you do produce energy. So both of that are correct. So I can cross out C and D. But then the fact that it produces heat energy It is this heat energy that allows you to harvest the energy. We don't just use the heat energy for nothing. We use the heat energy. When you're an engineer, you would know when you burn fossil fuel, this is what happened at power station, at power plant, power stations. So all over in Brunei, we have power stations. They burn fossil fuels. We get CO2, we get H2O. They burn. That means it's combustion. What does combustion do? Combustion is always exothermic. So that means it releases heat. What does the heat energy goes to? The heat energy goes to kinetic, because what happened is, if you're an engineer, you will know it. It's about generating electricity. Okay, perhaps I don't want to talk about the kinetic energy. I want to talk about the heat energy goes to electrical energy. That is what happened in a power plant. The energy that you release from the combustion of fossil fuels, this is a chemical change. That energy is converted to electrical energy. It's the same thing for a fuel cell. Therefore, this thing explains number one. Happy? So does not mean it's incorrect. It does explain number one. It's the very reason why it's used as a right. Next question. Anyone got any more question in this work?
13.
Question 15.
13.
13. 13. Heat energy is produced when hydrocarbon burns in air. So again, I just want to highlight this thing called combustion. Hydrocarbons is something you will learn more in year 11, but all your petroleums are hydrocarbons. They call it hydrocarbon products. So petroleum, crude oil, they are all hydrocarbons. Okay. So when you burn something in air, you are burning in oxygen, because we know that nitrogen, so around 78% nitrogen, around 21% oxygen. It is actually oxygen that support combustion, not nitrogen. Oxygen that support combustion. So this is balancing equation, isn't it? Why is this one wrong? Oh, I know why. Okay, that's because definition of hydrocarbons. Hydrocarbon means hydrogen and carbon only. Hydrogen and carbon only. You have got oxygen. It's not hydrocarbon. It's got oxygen. Hydrocarbon, hydrogen, and carbon only. No oxygen. This one has got oxygen. Okay, hang on. Let me just quickly take attendance. Just gonna screenshot that. And whoever is not around is not around. I guess our. Okay, anyway, so any other questions? It's good to have you with us, Nabila, because you never sent in the work. Anyway, next question. Any other question in this?
7.
Number 7. Number 7. Okay, there are a couple of reactions that you need to understand, right? So these are pictures. First of all, combustion in a Bunsen burner. Next time when you go back to the lab, when I turn on the Bunsen burner and heat up something, you should feel the outside of the Bunsen burner. It feels cold. That's because the gas inside is combusting. Outside is hot, so the surrounding gets hotter, but the system lost energy. So that's why the gas canister will feel cold. But it's exothermic because what happened to the system? The system loses energy to the surrounding. The reactants will have lower energy than the products. So if this is reactant, your product will be there. So, you know, you lose energy to the surrounding. It's negative. Enthalpy change, lose energy. This is the process of reaction. Exothermic is always, combustion of something is always exothermic. That's why B is definitely wrong. In terms of this, alkali plus acid, this was supposed to be your practical later this afternoon, but obviously, you know, things are unpredictable like that, okay? You also have this in the notes. Alkali plus acid is called neutralization. Neutralization involves this ionic equation from year 9. You know, H plus from the acid, pH below 7. OH minus from the alkali or base, pH above 7. They mix together, ionic equation. Show the ions, the charges must cancel out, the stat symbol must be there. You are not breaking anything. You don't break anything. Have a look at it. There's no bond in H plus. There is a bond, a covalent bond there, but this and this mix together, they react together and they form a new covalent bond. Could be that or could be the other one, but just bond forming. This is what you can say. Bond formation, bond forming is exo. You are not breaking any bond. You're just forming bond. So neutralization is always exothermic. Doesn't matter what acid, doesn't matter what alkaline, you always have this ionic equation, never changes. Whatever acid, whatever alkaline, you always have this ionic equation. That was what you learned in year 9, ionic equation. Neutralization is exothermic. You can catch the experimental tutorial video that I did with the combined science students in the same playlist for your this topic, yeah? Anyway, so between this and this thing is calcium oxide dissolving in water. Later on, you will learn more about group 2 chemistry as part of metals. This thing will give you calcium hydroxide plus, am I correct? Calcium hydroxide? Yep, that will give you calcium hydroxide, Ca2 plus, OH minus. Remember, this is number 1 thing that people always get tricked by. 2 of the OH minus, put it in a bracket like that. This thing is highly exothermic. Highly exothermic. Why? This is the water, but the water turns to steam. The water turns to steam. Why does the water turns to steam? I guess this is why people find it confusing. Okay? The water turns to steam. The water has to gain energy to go to steam. That is, simple change of state. The water is at room temperature, but it turns to steam straight away because it's very hot. Why? Where does the energy come from to turn the liquid water to gas? The energy comes from this reaction. This is the energy. That energy is used to turn the water to steam. And that thing is definitely exothermic because this reaction is exo. You release the energy, and this is the other reaction. I think people are confused about this. The other reaction will absorb that energy and turn it into gas. Yes, boiling is endothermic, but this reaction, adding water to calcium oxide, this is what they highlighted. They don't say the water turns to steam. Water turns to steam is endothermic, but adding water to calcium oxide release a large amount of heat energy. That heat energy turns the water to steam. Hopefully that makes sense there, which means you're only left with one answer. This thing, you will also learn it as part of group 2 chemistry. You need to heat it. If you don't heat it, there is no reaction. And guess what? This is one of the popular questions. Is this redox or is this not a redox? This is calcium 2 plus, calcium plus 2, calcium plus 2. This is oxygen minus 2 in a compound. This is oxygen minus 2. Calcium carbonate, the whole compound has 0 charge, plus 2 for the calcium. Carbon is what you want to find. I have 3 oxygens. Each oxygen is minus 2. So carbonate is going to be plus 6 minus 2. Carbonate is plus 4. This is CO2, 0 for the whole compound. Carbon is what you want to find. You have 2 oxygens. Each oxygen is minus 2 oxidation number. Again, this comes back to year 9 chemistry. So all the oxygen is minus 2. All the calcium is plus 2. All the carbon is plus 4. This is not a redox reaction. This is simply a thermal decomposition because you need to heat this one up for this to happen. Without heating it up, it just remains calcium carbonate. Thermal decomposition is an endothermic process there. Okay, next question. Anyone got any next question? Don't have any next question? Well, if you don't have any next questions, I guess that's pretty much it for this topic. Well, so far, you will have finished the notes. Anything you are unclear about, you will have gone back and do it yourself anyway. And I mean, this is the opportunity for you to, ask any questions. Okay, if you got all your question answered, you can leave anytime you want. But of course, you do a correction on your own, and you cannot say I haven't done the correction with you yet, because this session is essentially a correction. You will know that there are a couple of deadlines you need to fulfill, yeah? So the alternative to practical would be next Monday is the deadline. It only takes around 20 minutes in the real exam. So, you probably have around 20 minutes now if you have time, go through them. But your goal really is not to speed up and get everything wrong, because you are doing it as an exercise. If you want to do it in the time taken, make sure you're ready for the real test that will come, I don't know, 2 weeks from now, when school reopens. You will have the test on this topic, yeah? By then, you will have submitted all your work. I would have returned your work. I will have provided feedback, well, for the people who submitted. Maybe 1 or 2 people haven't submitted. I don't know. Okay. Any other questions?
Question 10.
Question 10. This is exactly what I said earlier about catalysts. Catalysts will speed up reactions. So here you have 2 energy profile diagram. You see here, the enthalpy change is from the start to the end. Catalyst is defined as a substance that speed up the rate of reactions, but itself remain unchanged. It is not a reactant. A catalyst is not a reactant. That's why it doesn't appear together with the reactant. It simply gives you this alternate pathway, and this alternate pathway has a low activation energy. How do I know it's low activation energy? Well, you can see here, this one here, from the start to the top of the peak, the green color one is lower than this blue color one without catalyst. So that means this reaction is faster. Imagine if you have to go up a hill. If the hill is lower, that means it's easier for you to get to the other side. If the hill is higher, it's more difficult for you to get to the other side. If it is easier to get to the other side, your reaction is faster. So lower EA means it's easier to overcome the activation energy, therefore reaction is faster. So that's the only thing you can tell. When I use this thing, the EA is lower, therefore the rate is faster. Less exo or more exo doesn't change, because if you could see here, starting point is the same, ending point is the same. From the start to the end, there is enthalpy change. Enthalpy change from that reactant level to the product level, that doesn't change. The value remains exactly the same. It is the activation energy that's the only one that changes when you use catalyst. Hopefully that makes sense there. Okay, any other questions? If not, feel free to leave. Okay, you don't have to stay, provided you know exactly what you need to do. Each topic has a learning objective. You have been given the syllabus, you have been given the notes. When you revise, you make sure that you can understand definitions, just like all the year 9 stuff. If you can't do definitions, then can't help you, okay? It's already stated in the syllabus. And if you can't do whatever the syllabus say, candidate should be able to blah, blah, blah. Can't help you, okay? It's because that's what the syllabus say. All right, any other questions?
6.
Number 6. So the rest of you, if you already have your questions answered, you don't really have to stay. Huh? This is another neutralization equations. I told you earlier, the H plus and the OH minus, you are not breaking anything, you are just forming something. So that is just the H plus and OH minus coming together to form this covalent bond. So you get this new covalent bond, the pink color one, just bond forming, not breaking anything. You don't break this, you don't break any bond at all there because there's no bond. You form this new covalent bond. Bond forming will always be exothermic. Neutralization has the same ionic equation, always exothermic. Now, what do we know? This is kilojoule per mole. The per mole there is actually for per mole of water form. That is actually an idea called enthalpy change or neutralization. So per mole of water form, you get this much. Neutralization always comes down to this. So you think about the balance equation, HCl and NaOH, that's your most common year 9 equation for neutralization. So find the mole of HCl, find the mole of NaOH. I don't add up the mole because I'm just doing this to make sure that which one is limiting and which one is excess. That's the purpose of me doing that here. Which one is limiting? Because if I want to know, if I want to do calculations in my mole calculation, I have to use whatever is used up. But here, 1 mole reacts with 1 mole. So 0.1 mole of acid reacts completely with 0.1 mole of NaOH. Nothing is in excess. They react in the exact amount. 1 mole is to 1 mole. This is mole. Concentration, 1 mole per dm cube. Volume is in cm cube. This is called solution. There is no such thing as hydrochloric acid as a gas because hydrochloric acid is a mixture. You do have HCl gas, but that is a pure substance. That is called HCl, or that is called hydrogen chloride. Is also in your year 9 dot and cross diagram. This is pure. HCl aqueous is a mixture. You cannot get HCl aqueous in the gaseous state as a mixture. They can only exist as a pure substance in the gaseous state. Solution chemistry means N equal to CV. This V is not for a gas, it's for a solution. Anyway, so this is kilojoule per mole of the water. If they react in the 1-to-1, So 1 mole of this gives me 1 mole of water. So I can just use either one. I will get 0.1 mole of water. Therefore, 0.1 mole of water multiplied by that, the mole and the mole cancel. I get this much energy being released because exothermic reaction release energy. Hopefully that makes sense there. All right, next question. Anything else you want me to go through? At the end of the day, you need to be able to do and explain in MCQ. Otherwise, you will struggle in the structured question as well. Any other questions, guys? Nothing else? Okay. All right. So if there's nothing else, then, yeah, we'll call it a day here. You have all the tutorials to go through online. You have your year 9 stuff. And actually, I might take this opportunity to go through electrolysis test. Do you guys have your electrolysis test with you? Okay, let's not, never mind. I leave you to do your electrolysis test first. You do the corrections, electrolysis. If you got any questions on that, we will arrange a different date to go through the test itself. I mean, there was the MCQ, and then there was the structured question as well on the electrolysis. You don't just put away your work, yeah? Otherwise, it defeats the purpose of feedback. If you don't like to hear what other people say, then you are certainly not going to improve. That is the reality of life, okay? And my job is not to show you the good stuff, it's to show you the bad stuff, okay? I think I'll probably just leave it there for today. I don't want to go through electrolysis today because I don't know. I mean, some people might not even have gone through the corrections themselves. So it defeats the purpose, right? Of going through things and then you going through your file and trying to find stuff just like that. So hopefully you spend some quality time going through corrections on your own, and take care. I'll see you guys sometime next week for lessons, and we'll go through the other work which you will submit on Monday, and there will be more work due sometime soon as well. Okay, thank you everyone.